So you guys are real chatty right now, which is great. It's also not great. So talk to me. Welcome to algebra. This unit is called equalities for a very particular reason. Up till now, we've been dealing with things called expressions. What is the difference, do you think, between a mathematical expression and a mathematical equality? An equals sign. Yeah, that is literally the only difference. As soon as you have this mathematical sign, we are now dealing with equalities. And so now this is where we're going to have to start to solve for things. This is where letters become involved, and letters represent unknown things, and we have to figure out what those unknown things are. So, we're some vocab here. Perhaps, this should be relatively easy, I think, to define some of these things. Variables. What is a variable? Someone can define that for us? Yes, Tammy. Letters. How about I say letters that represent unknown numbers? That's cool. I'm content with that definition. Does anyone want to give us an alternate definition? No, I see no hands. I'm not hearing a lot, so let's keep going then. What are some examples of variables that you have used in the past? Why? Because I'm asking. No. I know, I was messing with you. So like the letter Y. Okay? The letter X. Cool. Sometimes the letter A. Not which? Not I? No, we don't use I as a variable anymore. Because of that thing. What thing? Because of imaginary numbers. Now I represents imaginary numbers. So I'm going to make a list here of bad variables. Okay, so there are things we do not want to use as variables. Often you get to choose. I is a bad variable. What are some other examples of bad variables? Carmen. E would be not a great variable. X is a good variable. We like X. Sometimes we don't use X because it looks like multiplication, but X is a really common one regardless, and so you're going to want to get comfortable with that one. But there's other ones. Danny.
Is Z a good one? Because sometimes it looks like a 2.
Z is one that we use a fair bit actually as well, because X, Y, and Z form a nice little set. Yes, sometimes you have to change your things. So some of these things are going to involve you changing how you write to accommodate these things. Like B was a bad one for me because my B's would look like 6s, but then I just have to figure it out because B's otherwise a good one. Yeah. O, yeah, O is terrible. Why is O terrible? It looks like 0, right? We want to avoid O. There's another one that we typically want to avoid unless you write it fun. L? Is that what you said? Yes, correct. Lowercase l just looks like a what? 1. Which is why we typically write lowercase l cursive. When it's a variable, we write it like this. Okay? So there's a bunch we want to kind of avoid, especially when you're choosing your own. We don't just have to use the English alphabet, though. The Greek alphabet is open to us as well. The Greek alphabet's fun. It's things like this. Fish, which is alpha. This guy here, which is falling fish, also known as gamma. Then you got this guy, which is tent, which is also known as lambda. There's this one you may have seen before. What's that guy? Starts with a T, which is kind of a miscue because it actually starts with a th sound. This is theta. We use it to represent angles. There's another one here that we use. This one's phi. We also use it to represent angles. Also shows up in the golden ratio, if you're into art. Okay. So the English alphabet, the Greek, or in photography, sometimes it shows up there. The Greek alphabet is useful. There's 23 letters in the Greek alphabet. I, in one of my classes, used up all of the English, all of the Greek. And so my buddies and I decided to go back and learn some Hebrew. So we threw down the Hebrew alphabet because it's the next easiest one to write. Like, we didn't go into any of these awesome Asian languages because that would just get really involved. So we avoided the Asian languages. But we've got the English, the Greek, and the Hebrew actually opens up things to you. So let's identify some variables here. I've got some expressions. What are the variables here? Yeah, A and B. That guy there, that guy there. Variables here. X, nice and easy. Variables here. W, Y, and Z. Love it. Cool. What's a term? Moving on to the next thing. In an expression or an equation, what is a term? What do you mean? 4? Just 4. Like all numbers are terms? We're not sure. You're just guessing. It's good. I like guessing. I like that you're trying. Sometimes, unfortunately, the answer to what you're suggesting is sometimes it's a term, sometimes it's not a term. Does anyone know this word term here in math? Okay, all right, I'll give you a definition for it. Here it is. It is it can be a whole bunch of different things. It is either a single number, like 4, as 10 Meat said, comma, because we're going to make a list of things. The single number, a variable, comma, or numbers and variables multiplied It sounded like I was going to say something else after I said multiplied, but I'm not going to. So that's why we're going to call it that. It sounded like I was going to say something, but I'm changing my definition from last semester. We're going to put a star underneath here. And we're going to say terms are separated by addition or subtraction. I'm just using the symbols for that, not the words themselves. So a term is a single number, like 4, a variable, like x, or numbers and variables multiplied together, like 4x, and terms are separated by addition or subtraction. So here, what are my terms? 4a is one term. Give me another term, someone else. Carolyn? 3x. And the last one? Almost. It's not 7, it's negative 7. So my terms here are going to be 4a, 3x, and negative 7. Those are my terms. When you're dealing with subtraction, you have to include the sign in front. B. What are my terms there? Carolyn, I see that hand. There's only one term here. What is it? The whole thing. So my term is 78 ABC. The the whole thing. And then here in C, how many terms do I have and what are they? Careful. My terms are only separated by addition or subtraction. So what are my terms here? 4a over t is one term, and negative 10. So I got two terms there. Good. Cool? Comments, questions, concerns? Okay. There are kinds of expressions depending on how many terms they have. Monomial. Does anyone take a guess at what a monomial is? One. Mono is one, like a monocle. Like you have one fancy because you got the one piece of glass in your eye. A monomial is a one-term expression. So we've got a monomial. This is a monomial here. 78ABC would be our example of a monomial. A binomial is, Carolyn? It's going to have two because bi means two, like bicycle. It's a cycle with two. And we've got a binomial up here, 4a over t minus 10. And then a trinomial is going to be a three-termed expression because tri means three, like in trident, because that's cooler than tricycle. Triangles are lame. But it's also like triangle because it has three angles. You are right, but tridents are cooler. You can't stab anyone with a triangle. I guess technically you could. It has three pointy sides. Never mind, I take it back. Triangles are cool. Okay, so let's practice. I want you guys real quick here. Place a triangle around the monomials, a square around the binomials, and a circle around the trinomials. It's written right here for you. No, I put the triangle around the monomial because it's the smallest one and the triangles take up a lot of space. Try to stab someone with a triangle? The handlebars, you gotta sharpen those up. Okay, but try these though. Place a triangle around the monomial, a square, tricycles don't have chains, a square around a binomial, and the circles around the trinomials. Okay, we done? We're not done? Okay, here we go. So, which ones have triangles? Hands up, someone. Give me all the ones with triangles in them. Danny.
The first one.
X.
Second one.
The second one, 4a squared.
And then
B.
The second last one.
5mqn squared. Cool, those are my triangled ones. Which are my squared ones? Someone else. Carolyn. Y minus 5. There we go. And the circles are on the trinomials. That's going to be the other two. There you go. Cool. Constant. What's a constant? More definitions. More vocab. We good back there, gentlemen? What is a constant? Define for me a constant. What does it mean for things to be constant?
In general?
Yeah.
Continuous. Constant.
What do you mean?
It's just like it's
Did you just try and jinx me
yeah, you said what do you mean? And I said what do you mean
at the same time? Then I shouldn't be speaking, or I owe you a Coke. Okay.
I don't like Coke, so never mind.
Okay. Then you withdraw the jinx.
Yeah.
The rules of jinx are unflinchingly rigid. My wife and I still abide by the rules of jinx. Yeah.
A constant, like continuous, like it doesn't change.
It doesn't change. There it is. Okay. So a constant term, when we talk about things that are constant in math, constants are terms that do not change. So what kinds of terms do not change? What must they not have? They must not have a variable. Only what? No, a constant is a kind of term. A constant cannot have terms. A constant is a term that has no variables only. I think I heard someone say it. That you can only have a coefficient if you also have a variable. We're about to define a coefficient. A number, yeah. And typically it's a single number. When I say a number, I literally mean a number. 1. So one of the things that is important here, though, just like before when we were talking about terms, we want to include the sign in front. So here in 4a squared minus 5a plus 10, what's the constant? Positive 10. Okay, right there. Cool, and the next one, in B, what is my constant term? Negative 21. Love it. And then C, my constant term is, yes, Rebecca? Positive 3.7. Love it. Easy. Coefficients, I said you could only have if you have variables, so what's a coefficient? Carolyn, I saw that hand. The number multiplied by a variable. That is true, but you've got to be careful with this word multiplied, because what is the same as multiplication even though it looks a little different? Division. Division is the same as multiplication, just looks a little different. Because, for example, if I had something like x over 7, that's x divided by 7, that's the same thing as what if I write it as multiplication? How do I write x over 7 as multiplication? Yes, except I'm going to write it as 1 over 7 times x. We cool with how those are the same? So if I just had this guy here, x over 7, what's my coefficient? Not 7. If these are the same, what's my coefficient here? 1 over 7. So my coefficient here has to be 1 over 7. We good back there with gentlemen with the phone? I mean, if you're good, then by all means. But don't ask me questions later if we weren't paying attention because we were on our phones. So then what is our coefficients here? Yeah, Carolyn? Coefficient here is 4. What's my coefficient here? If there's nothing written, what's the number we assume is there? 1. So my coefficient here is 1. What's my coefficient here? It's going to be 4 over 5. How about this one? It's going to be all of that there. Yeah, the 2 over 7. And then what's my coefficient here? -1. Good. Ugh. Comments, questions, concerns? Okay, cool. Flip the page. Almost done. Nope. I'm not done yet for today. So, I'm going to leave that note at the top blank. I don't think it's necessary. We'll see what we can do with it, without it. So we can substitute things into expressions and then evaluate them. So if I have an expression here, 3x plus 1, and I say something like this, evaluate for x equals 2. What does that mean to you? Have you done something like this before? Okay, yeah, so I'm going to take my value. So I'm telling you that x equals 2. I'm going to take this value 2, and I'm going to replace x with it in my expression. So one of the easy ways to make sure that you're doing this properly is to take the variable that you're replacing and put a set of brackets where it sits. So I'm going to rewrite this thing as 3 bracket bracket plus 1, because that is where my variable was. And for my variable, we're told to evaluate for x equals 2. So wherever there was an x, I'm going to put 2 in there. And I'm just going to evaluate this thing. So you guys have already said kind of before what I did, what I'm supposed to do. So what is it? 3 times 2 is 6 plus 1 is 7. And if I want to evaluate this thing for x equals 3, same thing. I replace my variable with a set of brackets. I put my value that I want to substitute inside that bracket. Evaluating 3x plus 1 for x equals 3 is going to give me what value? Nika, 10. Good. Love it. How about the next one? 5 minus 4x, and I want to evaluate for x equals -2. I hear, ooh, careful. 5 minus -8, which is? Which is? 13. Okay, so that is the correct value. How did we do it? So we want to be careful here. The reason I'm kind of particular about the brackets is because we want to make sure we actually follow the math properly. So if I've got 5 minus 4 and then I throw these brackets down, I want to put my -2 inside there. You could look at it the way these ladies up here at the front did, or you could say, well, I've got -4 times -2. Did I say that before? With the coefficients, we also include the sign out front. So the coefficient here is going to be -4. So -4 times -2 is +8. So this is going to become 5 plus 8. It's going to equal 13. And then evaluating that thing for x equals 0, what's that going to give me? It's going to give me 5. Nika, was that you? Yes. Right? Because I'm going to have 5 minus 4 times 0. What's 4? No, what's -4 times 0? What's anything times 0? 0. So then I'm going to have 5 minus 0. 5 minus 0 is? If you're subtracting nothing. Cool. We'll just wait. Is that a new sweatshirt? Oh, the extra button. Don't lose it. Wait, did that sweater have buttons? Okay. Okay, last one. We're almost done here. Often we're going to get... Oh, yes, sorry, Carolyn? Oh, you wanted to do it. Often we're going to get expressions here that are embedded into word problems. So you'll get the height of the ball thrown upwards is given by the expression h equals 30t minus 5t squared, where h is the height and t is the time. So as the ball is moving, as time is progressing, the height of the ball is changing. The height of the ball is changing given this equation here. So the question says, what is the height of the ball in meters after 1 second? So that suggests that t equals what? T equals 1 is the thing that you have to understand there, that's what that means. So what I'm going to do now is I'm going to take my expression that we're going to give, and we're going to replace 1 everywhere there's a t. So Carolyn? Unless otherwise defined, yes. Okay, so that's how we're going to write it. I want you to show me all your work. Carolyn, finish it up. You betcha. After 1 second, the ball is at 25 meters. And the ball is moving very quickly. Last one here. What is the height after 2 seconds? How would I do this? Yeah. Okay. And again, I want you guys to write it the way I'm writing it. Replace the variables with the set of brackets and put your value inside there. Make sure, that'll help you make sure you get the bed mass done properly. So what do I got here? $30 times 2 is 60 minus, yeah, keep going. Two squared is? 5 times 4 is? 20, okay. And then 60 minus 20 is? 40. 40 what? Meters. Okay, so welcome to Unit 3, equations, or equalities rather. I am going to give you guys some practice. You also, I mean, you've got your test to study for, but I'm going to give you some practice out of here. So use this next 15 minutes well. If you flip the page, yeah, what I want you to do there's a lot of practicing here. You don't have to do all of it. Here's how I'm going to cut it down for you. I want you guys, so the questions here will say, this is not extra practice. I want you doing all of this, pages 1 to 4. We'll say questions number, so you're going to do 1 to 3. Yeah, sorry. 1 to 3, you can do all of it. There's only one. It's only one question each. Questions 4 to 14. You guys are going to do aces. And then I want you to do 15 and 16. I've explained to you what aces mean, right? Aces mean every other letter starting with A. A, not B. C, but not D. E, but not F. G, but not H. You just keep going until you run out of letters. See, that's what students have said in the past. Well, there is no S, so I stopped. Well, no. It's aces. Aces plural. So ACEGIKMOP. Those ones. No, not P. Q. O and then Q. Maybe unless I skipped it. I don't know. You understand what I mean. So there's 15 minutes left, and this stuff should be relatively easy. It's the very first lesson that we've done. Lots of this should hopefully be review. On your market, say giver. Welcome back. Happy to have you here. Question 1 to 3. You're doing all the pages. You're doing all the pages, but you can do questions 1, 2, and 3. And then you're going to do 4 to 14 aces, and then 15 and 16. Oh yeah, there should be space enough for you. Yeah, if you can fit it on the paper, you can write it on the paper, but if you can't fit it in there, then by all means, I've given you a lined coil-bound book. And if you need another one of those, I think I still have some on the back there. Here we go. Yes, Rebecca.